The first lesson in Unit 8 deals with the interior and exterior angles of polygons. This particular lesson is going to require you to memorize a couple of formulas and several vocabulary words. Our learning target is I will identify polygons and I will find both the interior and exterior angle measures of polygons. You will turn that into your own essential question, please. To begin with, a polygon is a plane figure, which means it must exist on a plane, that meets the following conditions. It is formed by 3 or more segments called sides. No 2 sides with a common endpoint are collinear. And each side intersects exactly 2 other sides. In other words, if we go back to what you learned in elementary school, it has to have straight sides, no curves. It can't have any holes or gaps, and it can't have any overlaps. The sides are the segments that form the polygon, and the vertices, or vertex, is an endpoint of a side. We say that if no line contains a side of a polygon, is in the interior of the polygon, it is convex. All right, so what does that mean? When I look at this quick sketch of a pentagon, if I extend the side, I do not go through the inside of the polygon. Same here. The third, I do not cross the inside. I do not cross the inside. I do not cross the inside. So this is a convex polygon. A concave, otherwise known as non-convex, and yes, you'll see both words pop up in different math books. On the other hand, when you extend a side, you do cross through the interior, right there. That makes this concave. If all of your sides are congruent, it is equilateral. You have seen equilateral triangles. Now you're going to see equilateral quadrilaterals, pentagon, hexagons, octagons, and so on. If all of the interior angles are congruent, it is equiangular. Now in triangles, equilateral and equiangular go together. That is not necessarily true as you look at other polygons. A polygon that is both equilateral and equiangular is regular. Irregular would be a polygon that is neither equilateral or equiangular. If it doesn't meet one of the criteria, it is irregular. And a diagonal is a segment that joins 2 non-consecutive vertices. So sketching a quick quadrilateral here, there's my diagonal, non-consecutive, not side by side, not connected by a side. Alrighty, absolutely no geometry lesson is complete without some theorems. So, what are the theorems for today? Well, the sum of the measures of the interior angles of a quadrilateral is 360 degrees. We have a polygon interior angle theorem that says if you have a convex n-gon, what does n mean? The number of sides. Okay, so I could ask you for a convex 22-agon or a convex 119-agon. All right, but we have a formula, 180 degrees times the quantity of n minus 2, n being the number of sides. The corollary to this is that we can find each interior angle of a regular n-gon simply by dividing our sum by the number of sides. Okay, that only works if it's regular. Okay, if you have a polygon and the angles are not all the same, this corollary will not work. Continuing with some more wonderful theorems, the polygon exterior angles theorem says the sum of the measures of the exterior angles of a convex polygon is 360 degrees. It doesn't matter how many sides you have, this is always true. So how do you do this? We take our pentagon, we extend the side, there's your first exterior angle. Okay, extend. Here's your second exterior angle. Extend. There's the third one. Okay. Extend. There's the fourth one. And coming back here, I've got to duplicate a color, extending to get the fifth. If you're actually drawing these exterior angles, I suggest you go clockwise or counterclockwise on all of them. In this case, I went clockwise. There's a corollary to this theorem. Okay, it says that if we want each exterior angle of a regular n-gon, we simply take our sum and divide by the number of sides. Okay. So you need a guiding question here. All right, so how do we decide whether or not we have a polygon? Okay, looking at A, this would be no, because we have a line through the interior, and that violates the second rule. We have a segment connecting 3 vertices. Right, it can only connect to 2. So connecting to the consecutive vertices here was okay, but going through the interior was not. Letter B is another no. We're not allowed to have curves. Sides must be straight. All right, letter C looks good. That even looks like a trapezoid to me. Okay. Letter D, everything's straight, no curves, no lines through the inside, no gaps. There's another yes. Letter E, that's a big old no. Can't have the gap. Sides must connect. All right, hopefully that's a review from elementary school. You need another guiding question here. How do we determine whether or not a polygon is concave or convex? Well, to do that, you extend the sides. As long as none of the extended sides cross the interior, the polygon is convex. If any of the extended sides do intersect the interior, it is concave. Okay, so looking at this first one, I've got a convex. The second one, however, look at that, I'm going through the inside. Concave. It only has to go in the interior one time, and you have a concave polygon. All right, we need another guiding question here. And this time we're looking at whether or not a polygon is regular. So in order to be a regular polygon, it has to be equilateral and L-A-T-E-R-A-L, equiangular. Okay, so looking at letter A, that is marked with all sides congruent. We are meeting the equilateral criteria. However, it is not, this one's going to be irregular. It's not equiangular. I have an acute angle here, but I have a reflex angle there. So there is no way this is equiangular, not equiangular. Okay, looking at letter B, that is a rectangle. It's irregular. It is equiangular. I have 4 right angles, but it is not equilateral because I've got a short side and a long side. So not equilateral. All righty. What kind of shape do we have here? 1, 2, 3, 4, 5, 6, 7, 8 sides. That's an octagon. And all of my sides are marked congruent. All of my interior angles are marked congruent. So this one is regular. Yes, by the way, you are expected to know the names of your polygons. 3 sides triangle, 4 sides quadrilateral, 5 is pentagon, 6 is hexagon, 7 is either septa, S-E-P-T-A, or sexta, S-E-X-T-A, gon, octagon, nonagon, decagon. Okay, look up an 11agon. 12agon is dodecagon, and after that we just name the sides, 13agon, 14agon, 15agon. But I will offer bonus on the first quiz if you know the name for an 11agon. Alrighty, you will need a guiding question here. And in this section we are finding the measures of interior angles. So let's see, I've got 1, 2, 3, 4. This is a quadrilateral. It doesn't appear to be any special kind of quadrilateral, but that does mean that the sum of my interior angles has to be 180 degrees. So 118 plus 5x plus 3x plus 10 plus 72 equals 180. Oh, sorry, 360. Apologize for that. We've been doing triangles for so long, my brain immediately goes to the triangle. Combine your like terms and you get 8x plus 200 equaling 360. When you solve that, x is 20 degrees. We already know the measure of angle T and the measure of angle S. So the measure of angle U, watch your notation, ladies and gentlemen, is 100 degrees. And the measure of angle V is 70 degrees. Notation can cost you a lot. Looking at quadrilateral ABCD, I can tell you that we're going to have a theorem later in this unit that will tell you for sure that this is an isosceles trapezoid. It's a quadrilateral, so it will add up to 360. So 4x plus 4x plus 2x plus 2x equals 360 degrees. That's 12x equals 360. So x in this case is going to equal 30 degrees. The measure of angle B equals the measure of angle C. They're both 4x. So that's going to be 120 degrees. And the measure of angle A will equal the measure of angle D because they are both 2x. That's going to be 60 degrees. Find the sum of the interior angles of a 15agon. Well, I need that sum of the interior angles formula, which is 180 degrees times n minus 2, with n being the number of sides. So 180 degrees times 15 minus 2, and 2,340 degrees is our answer. Simple substitution, but watch your notation and make sure you have the degree sign. What is the measure of each interior angle of A, and this should say regular 21agon, in which case we take our sum of an interior angles formula and we divide by the number of sides. So let's see here, 180 degrees times 21 minus 2, all divided by 21. in this case, 1,140 divided by 7. That's going to give you a decimal, and you know I do not take decimals. So make sure you give me a fraction that is simplified. All righty. You're going to need a guiding question here as we talk about exterior angles. Find the value of x in the diagram, then find the value of each angle. All righty. Exterior angles, no matter how many sides you have to add up to 360 degrees. Now, as I look at this, this time they went counterclockwise around as they did my exterior angle. So x plus 2x plus 32 plus 2x minus 12 plus, don't let this one fool you, there's an exterior of 90 degrees right there. 90 equals 360. Combine your like terms. 5x plus 110 equals 360 degrees. So x is going to equal 50 degrees. Now, in this case, they did not label my angle, so I'm just going to have to write the degree measures directly onto the diagram. That one's good. This one's going to be 100 minus 12, 88. And I've already marked that one, but you could go ahead and write it in, 90 degrees. Okay, our next shape up here is a hexagon. And it is a regular hexagon because it is equilateral and equiangular. Because it's equiangular and all of these interior angles are the same, all of the exterior angles are going to be the same also, right? We have 1, 2, 3, 4, 5, 6. And again, I went counterclockwise around that particular shape. So 6x has to equal 360 degrees. X is going to equal 60 degrees. Knowing that, can you quickly tell me the interior angle measurement? And you should be able to using a linear pair. The exterior angle plus the interior angle has to equal 180 degrees. They form a linear pair. So the interior angle measure of a regular hexagon is 120 degrees. If the exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So we're going backwards, right? We know that the sum will equal 360. Divide that by the number of sides, and it has to equal 12 degrees. Okay, so a little algebra. Multiply both sides by n. 360 equals 12n. Divide both sides by 12, and you have 30 sides. What is the measure of each exterior angle of a regular 24-agon? Okay, so my formula is 360 degrees divided by the number of sides. So 360 divided by 24. Each exterior angle will measure 15 degrees. Now here, oops, edit, undo. Come on. Undo the drag and drop. There we go. Here is your non-real life, real life example. And this was actually on the SOL several years ago. The only reason I can come up for this is you are grounded and you are in your room and your mother has taken everything out except for this rug, which is beautiful, and your protractor. And for whatever reason, you want to know, you are so bored, the measures of the angles in a hexagon. Don't you love how we make these real life? All right, so 4 of the angles have a measure of 150, and the other 2 angles are congruent. So my 4 obtuse must be my 150. and they're telling me the two acute here are congruent to each other. So our formula for the sum of the interior angles is 180 degrees times n minus 2. So 180 times 6 minus 2, and the sum of the measures here has to be 720 degrees. All right, so 4 times our 150 degree angles plus our two congruent angles has to equal 720 degrees. So each of our congruent angles is 60 degrees. I hope none of you are that bored this weekend. You owe me a summary and some guiding questions.